Hello, good day, everybody. So, you're welcome to the Chem Lab Chemistry Mastery Academy. Today, or rather, in our SS1 third term scheme, we're going to be looking at these topics. We have here acids, bases, carbon 2 oxide and carbon 4 oxide. We have coal, we have metallic carbonates, we have introduction to hydrocarbons, and we have applied chemistry. Now, today we're going to be starting with acids. Now, what are acids? We have here an acid is a substance which in aqueous solution produces hydrozonium what? Ions, that's H3O plus. Now, first of all, let's understand this. When we said which in aqueous solution, what we basically mean is this. When you take an acid and you mix it with water, what happens is that it releases its hydrogen ion. And then when it releases its hydrogen ion, that hydrogen ion goes and adds itself to the water, forming what we call hydrozonium ion, H3O plus. So basically, what it means is this. One, an acid has an hydrogen that it is willing to release. Are we following? That it is willing to what? Release. So we can say that an acid is a proton donor. An acid is a what? A proton donor. And proton, as we all know, is a positively charged what? Atom. Or a positively charged what? Particle. Exactly. Now, let's write some equations to better explain this. Now, let's take an example, HCl. HCl, this is hydrochloric acid. Now, when you add water, you mix it with water. So let me ask a quick question. Do you add acid to water or you add water to acid? Okay, good. You actually add water to acid, not acid to water. Now, if you add acid to water, because acid is very corrosive, it has this ability to create some form of flare in the air. Pa, 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 pa. And when that happens, when it splashes on a person, what happens? It can cause the person's skin to get what? Burns. So rather, what do? You add water to acid. Now, so when we add water to acid, remember we said an acid is a substance which in aqueous solution, that is, which in water produces hydrozonium ion. So HCl plus what? H2O will give us what? We would have this hydrogen here add up itself to this what? H2O. And then we now have how many hydrogen? We now have 3 hydrogen, H3O plus, which is called an hydrozonium what? Ion. Then we have plus Cl minus. Okay, so moving further, acid can be categorized into 2 groups or classes. So in classification of acid, we have organic acid and we have inorganic acid. Now, organic acid basically are those acids that their source is from natural products, from living things, particularly what? Plants and what? Animals. Okay, so the word organic means natural. So organic acids are those acids that are gotten from natural products, such as plants and what? Animals. Now let's look at some organic acids that we have here. Now we have ethanoic acids, which is CH3COOH. This is ethanoic acid. Now, where can we find ethanoic acid? You can find ethanoic acid in what? Vinegar. Vinegar is what? An alcohol. Then we have lactic acid. Lactic acid can be found in your milk. We have citric acid. Citric acid can be found here in your lime and your lemon. Now, if you notice these different sauces that we have here, if you taste them, they have a sour taste. What do I mean? When you taste them, they have this shocking sensation. They have this shocking sensation on your teeth when you taste them. Okay, so that shocking sensation on your teeth is what we call the sour taste, and is as a result of the acid that is present in these what products. So we have amino acid, which is found in proteins. We have fatty acid, which is found in fat and oil. We have ascorbic acid, otherwise known as vitamin C, which is found in what? Oranges. All these are what? Organic acids. Okay, based on the fact that their source is natural products of plants and what? Animals. Now we also have inorganic acid. Now inorganic acid basically are those acids that are made by man, or by they are formed from what? Non-natural product, or from mineral elements. Okay, so their source is not natural product. Their source are what? Products that are not from natural what? Source. Okay, so basically inorganic acid has to do with you combining the various elements that make up the acid. For example, now HCl is a combination of what? Hydrogen and what? Chlorine. Okay, so HCl is a combination of hydrogen and chlorine. That means HCl is an inorganic acid. So HCl is formed when you bring in hydrogen gas plus chlorine gas. Okay, now when you bring in hydrogen gas plus chlorine gas, you will form 2HCl. Okay, then you take this 2HCl and dissolve it in water. Now, when you take this H2HCl and dissolve it in water, you will now successfully form what? Hydrochloric what? Acid. I believe that's clear. So, inorganic acid, now we have hydrochloric acid. The formula is HCl. What are the constituents? What makes it up? Hydrogen and what? Chlorine. Then we have tetrahydrosulfate 6 acid, that's H2SO4. That's another acid. What makes it up? We have hydrogen, sulfur, and oxygen. Then we have triazonitrate 4, HNO3 acid. What makes it up? Hydrogen, nitrogen, and oxygen. Okay, now acid also can also be grouped into another category based on their strengths. Based on their strength. So when you are grouping acid based on their strength, we have strong acid and we have weak acid. Now, what is the distribution factor between strong acid and weak acid? Now, strong acids we have here are acids which ionize completely in aqueous solution. Are acid which ionize completely in what? Aqueous solution. What do we mean by ionize completely? What we mean is that strong acid are those acids that give all of their hydrogen in the chemical reaction. They give all of their hydrogen in the chemical reaction. Now let's look at an example. I will use HCl, hydrochloric acid, as an example. Let's just clean everything. Now HCl. Now HCl, this is a strong acid. Why do we say this is a strong acid? We say this is a strong acid because when it is reacting, let's say it's reacting with an alkali, sodium hydroxide. When it's reacting with this alkali, this aqueous base, okay, when it is reacting with it, all of this hydrogen that it has, it will give it out. It will give it out. So because it gives out all of this hydrogen that it has, automatically that places it on the category of what? A strong acid. That's why we say that strong acid are acids that ionize completely in what? Aqueous solution. So when we do that, we now have what? This is made of H plus Cl minus. This is made up of Na plus OH minus. So the plus here will go to with the minus here. So we have NaCl plus this minus we go to this plus here. Now this one always goes together because it is a what? Is a radical. So OH minus, we go with this H plus. Now how many H do we have? We have 2, right? So we have H2. How many O? We have 1. So this reaction that we have here has a name, and it is called neutralization reaction. Neutralization reaction is a reaction that involve the reaction between an acid and an alkali or a aqueous base to form salt and water only. Exactly. All right, let's move further. Okay, let's give another example of a strong acid. What we have, if you look at what we have on the board, we have H2SO4. H2SO4. This first one. That's a strong acid. We have HNO3. Okay? So what they basically mean is this H2SO4, when it's reacting, it will release all of the hydrogen that it has. Okay, this HNO3, when it's reacting, it will release all of the hydrogen that it has. As you can see here, what do we have here? We have 2H plus. All of the hydrogen is out. Then SO4, 2 minus. Okay, moving further. Then we have weak acid. Weak acid. Now, if strong acid release all of its hydrogen ion, then weak acid does not release all of its hydrogen ion. Okay, so it means that for weak acid, when it's reacting, it only releases what? Part of its what? Hydrogen ion. That means weak acid are acids that do not ionize completely in aqueous solution. Or weak acid are acids that ionize partially in aqueous what? Solution. While strong acid are acids that ionize completely in aqueous solution. Now, there's what we call basicity of an acid. Basicity of an acid. Now, basicity of an acid has to do with how many hydrogen of that acid can be replaced by another what? Element or compound or radical. Are we following? So if it is only one hydrogen that can be replaced, if it is only one hydrogen that can be removed from the acid, then we say that acid is monobasic. That is, the basicity of that acid is monobasic. If it is two hydrogen that will be removed from the acid in the course of the reaction, we say that acid is what? Dibasic. Or you can put it this way: if that acid has only what? One hydrogen ion that can be replaced, we say that the basicity of that acid is what? Monobasic. Let's look at what we have on the board. We said the basicity of an acid is the number of replaceable what? Hydrogen ions. Is the number of replaceable what? Hydrogen ions. So basically, the focus is on how many hydrogen ions can be what? Replaced in the acid. How many hydrogen ions can be removed from the acid during the course of what? The reaction. So we have some examples. I wrote an line. Let's look at this first example that we have here. HCl plus NaOH. Now in this HCl, how many hydrogen do we have here? 1, right? Look at the product. Look at Cl. Now the hydrogen was removed, right? Because here we have HCl, in the product we have NaCl. That means the Na, that is sodium, took the place of what? Hydrogen. That is, it replaced what? Hydrogen. Now, how many hydrogen did it replace? 1, right? So it means that this HCl is what? Monobasic. That means the basicity is what? Monobasic. Exactly. Same thing applies to others. Like this H2SO4 now. Huh? Now the H2SO4 reacts with, let's use the same base. There are other bases we could actually use. NaOH. Now, when it reacts with NaOH, it will form Na2SO4 plus H2O. Now, look at this. Na took the place of this entire one. Remember, it's two hydrogen that we have here. So Na took the place of what? That hydrogen. So how many hydrogen do you have here? Two, right? So it means that two hydrogen were replaced based on what we have in the product, comparing it to what the reactant. So H2SO4 is dibasic. The basicity of H2SO4 is what? Dibasic. So now let's look at this reaction. Let's balance it. We have Na2 here, so it means that we have to put 2 here somewhere. Now automatically putting 2 here means that Na is now 2, which we have here. Now O is now how many? 2 here. 2 plus this 4, that's 6. So O is 6. But on this side is how many? We have 4 and we have 1 here, that's 5. So we need to add 1 more here. Now, if I put 2 in front of this water molecule, I would have made H2 to be 4, and it's 4 here. 2 times this, 2 plus this 2, 4. And then O to be 6. O, 4 plus 2 times this O is what? 2, 6. I want to assume that we're already familiar with that because that's part of what we taught in our second term work. You can refer back to our second term work to find out writing and balancing of chemical equation. Don't want to really go deep into that right now. So let's continue. Now let's look at the physical properties of acid. One of the physical properties of acid is that they have a sour taste. Remember that instance I gave you where you have fruits that when you eat the fruit, it has this shocking sensation in your teeth. It's as a result of the acid. That shocking sensation is a sour taste. Then acid turn blue litmus paper to red. So if you want to check, because acid and water, they look alike. So in the laboratory, you want to tell which is which. Of course, we know that we don't take fruit to the lab. But eventually you want to determine which is which. What do? Take a blue litmus paper, put it in the liquid that are similar. That liquid that changes that blue litmus paper to red, that particular liquid is an acid. That's why we said they turn blue litmus paper what? To red. Then we have, they are corrosive in nature. They are corrosive in nature. Now, what do we mean by corrosive? They can burn. So when an acid comes in contact with your skin, it will what? Burn your skin. That's why they are corrosive in nature. Then another thing is that when an acid comes on a metal, it dries it up and causes it to rust faster. Okay, that's because of its corrosive what? Nature. Then acid in aqueous solution, they conduct what? Electricity. So what it means is this: when you take water or liquid and mix it with acid, automatically that acid becomes a good conductor of what? Electricity, because when it mixes with a liquid or water, it will release hydrogen ion. And of course, you know, hydrogen ion is a positive ion, is a positive charge. Are we getting it now? All right. So the chemical properties of acid. Acid reacts with what? Metals. Acid reacts with what? Metals, like we have here. So we said acid, they react with metals to liberate hydrogen gas and salt of metal. So what we mean is this: when an acid, what we mean is this: an acid can react with a metal, and when it reacts with a metal, it will form a salt and hydrogen gas, like we have here. So HCl is reacting with zinc. Now, what does it form? It forms zinc chloride. Zinc chloride is a salt, and it also forms what? Hydrogen gas. Okay? Then, when H2SO4 reacts with what? Magnesium. Magnesium is also a metal. It forms what? MgSO4, magnesium sulfate, and what? Gas. Magnesium sulfate is also a salt. Exactly. So acid can react with what? Metal to form the salt of that metal and also hydrogen gas. Now, acid reacts with soluble bases We have given that instance several times. Look at it on the board. Okay, so acid react with soluble bases. Now, what are soluble? Another name for soluble bases are what? Alkalis. Okay, so acid react with soluble bases to produce salt and water only, and that reaction is called a neutralization what? Reaction. So it means that if I want to neutralize an acid, that is, if I want to remove the acidic nature in an acid, all I need to do is to what? Mix that acid with what? A soluble base or with an alkali. Is that clear? All right. Moving further, let's look at some of the examples we have on the board. So H2SO4 reacting with what? KOH. Now, KOH is a soluble base. Remember, when we wrote on the board, we used sodium hydroxide, right? But now, in this other example, we have another example using potassium what? Hydroxide. So when H2SO4 reacts with potassium hydroxide, it forms K2SO4, which is a salt, and then water. Now, it is not only an hydroxide that an acid can react with. An acid can also react with an oxide. Another example, HCl reacting with what? Calcium oxide. Okay? We produce what? Calcium chloride is salt and water. Exactly. So, acid react with soluble base to form salt and water only. These are the chemical properties. Now, next up, we have acid reacts with what? Triazocarbonate 4 salt. Triazocarbonate 4 salt to liberate carbon dioxide, salt, and water. That means if I want to produce carbon dioxide, what do? I can take triazocarbonate 4 salts and mix it with acid. I will form what? Carbon dioxide, salt, and what? Water. So, HCl plus what? This is the triazocarbonate what? 4 salt. Na2CO3. Na2CO3. That's triazocarbonate what? 4 salt. When it reacts with acid, it will produce carbon dioxide, salt, and water. Okay? Now, how do we prepare acid? How do we prepare acid? Preparing acid is very simple. Now we have here, acid can be prepared by using the following what? Methods. Acid can be prepared by using the following what? Methods. There is what we call acid anhydride. Acid what? Anhydride. Coming, let's clean what we have here. Acid anhydride. Acid anhydride. Now, what are acid anhydrides? What are acid anhydrides? Now, acid anhydrides are those substances that when you mix them with water, they will form an acid. When you mix them with water, they will form an acid. That's why we call it acid what? Anhydride. Okay, so it means that when you take an acid anhydride and you mix it with water, at the end of the day, what will you get? You will get an what? You will get an acid. So that's one way of preparing what? Acid. Now, some of the acid anhydrides that we have SO2, we have CO2, we have CO, we have NO2, we have SO3. Now, let's work with SO2 first. Now, SO2, acid anhydride, plus water. Remember, we said that acid anhydride are substances that when you mix them with water, they will form an acid. Now, we have SO2 plus water. SO2 plus water will give us H2SO. Now, 2 oxygen plus 1, 3. So, it will give us H2SO3. That's for this. So you see, we have succeeded in forming what? An acid, which is H2SO3. Then we have CO2. The same pattern. CO2 plus water will give us H2CO3. Okay? Then we have another one, SO3. plus H2O. So we have H2SO4. You remember this one now? We have been using it severally. Good. So that's that. That's one way to prepare what acid, by mixing acid anhydride with water. Now, another way to prepare acid is by combining the element that make up the acid. By combining the element that make up the acid. I gave you an example at the beginning of this class. When you want to form hydrochloric acid, what do? You take hydrogen gas, you take chlorine gas, you mix them together. When you mix them together, you will form hydrogen chloride. Now you take that hydrogen chloride and mix that hydrogen chloride with water. When you mix the hydrogen chloride with water, you will end up forming hydrochloric what? Acid. That's why we have on the board burning hydrogen in chlorine in the presence of activated charcoal. Burning hydrogen in chlorine in the presence of activated what? Charcoal as the catalyst. So the essence of that activated charcoal is to hasten up the what? Formation of that hydrogen what? Chloride. So it is what? HCl gas, hydrogen chloride gas, which you will dissolve in water to form what? Hydrochloric what? Acid. I've explained that. Now, another way to prepare acid is still under the combination of constituent elements. Now, we have heating hydrogen gas and bromine vapor. Heating hydrogen gas and bromine vapor or bromine gas. So, when you take hydrogen gas and bromine gas and you join them together, you will form what we call hydrogen bromide. Now, when you take the hydrogen bromide and you mix it with water, you will now form what we call hydrobromic acid. Are we following? And you will have the reaction on the board. Now, this particular one, you use platinum as a catalyst. You use platinum to hasten up what? The reaction. Of course, we know that catalysts only help to hasten up the reaction. They do not form part of the product at the end of the reaction. Exactly. All right. Now, still on chemical properties, still on preparation of acid, we have by displacement of a weak or more volatile acid from its source. Now, acid plus a soluble base will give us salt and water, right? Now, that salt and water that's formed, you can take that salt and water through a process to extract the acid that is in it. That's what this particular one is talking about. By displacement of a weak or more volatile acid from its salt by a stronger or less volatile acid. Okay? So, displacement of the more volatile hydrogen chloride from metallic what? Chloride by the less volatile concentrated tetraazosulfate 6 acid. So basically, what are we saying? Look at this. Salt and H2SO4. Now, this salt that we have here was formed when you mix hydrogen chloride plus what? Sodium hydroxide. I've cleaned it from the board, but you remember that example, right? When you would mix hydrogen chloride plus what? Sodium hydroxide. Is it not so? That's when this salt was formed. So, this salt that is now formed, you will not take the salt and mix it with a stronger acid, okay? And mix it with a stronger acid because H2SO4 is much more stronger than HCl that was responsible for forming this. So you mix this salt with what? H2SO4, a stronger acid. When you do that, you will end up forming an acid, which is this NaHSO4. This is what we usually call acidic salt. Acidic salt, but it still has that nature of what? An acid. Do you get? All right. Okay, and then look at the other acid that was responsible for forming this, HCl. You see that we have formed two acids here. The main one, HCl, and the one that has the nature of an acid and the nature of a what? A salt. Hence we call it acidic what? Salt. Then we have another way, still under this heading, displacement of weaker triazoborate 3 acid from borers. Okay, still the same principle. This, what do you call it now? Borers, is formed, is a salt actually that was formed when you mixed an acid with a soluble base. Okay, then we'll now add an acid to the salt. When we add an acid to the salt, we'll end up getting that acid that was mixed to form it. What do we have here? So we have H3BO3. H3BO3. This is the acid that was mixed with a soluble base to form this borous salt. Okay, you see, we have succeeded in extracting it out by what? Adding another acid to that salt that was formed. All right. Now, what are the uses of what? Acid. In the industry, acid is used to make different chemicals. Acid can be used to make your fertilizer. It is used to make a detergent. It is used to make drugs. Then number 2, acid is also used to make those things that we use to dry materials. We call those things drying agents. So acid can be used to make drying agents. Remember an example I gave you that when it splashes on your skin, what happens to it? What happens to your skin? Your skin will burn, right? So what are we saying? What happens is that when it splashes on your skin, it is a water lover. It loves water. It will extract the water. And in the process of extracting the water, it causes that place to look like it was burnt. Okay? In the process of extracting the water. So, acids are used to make drying agents. They are used, or rather, they are used as drying agents, not to make drying agents. They are used as drying agents. They are used as what? Oxidizing agents. And they are used as what? Catalysts. They are used to fasten the process of a chemical reaction. Okay? Now we have what we call pH scale. pH scale. What is pH scale? pH scale basically has to do with a way of measuring whether a substance is acidic, whether a substance is alkaline, or whether a substance is none of them. Now, on the pH scale, we have from 1 to 14. And in the middle, we have 7. Now, when you take any substance and put it on the pH scale, the one that is below 7 is acidic. Yes. And the one that is above 7 is what? An alkaline. So, listen, follow me now. From 7, okay, the one that is at 7 is neutral. That is, it is neither acid nor base. It is neither acidic nor alkaline. So, look at this. This is neutral. 7 is neutral. Now, you go to 6. By the time you get to below 7, 6.9, it is acidic. But 6.9, despite the fact that the number is high, is less acidic compared to 1. That means 1 is more acidic than 6.9. So it means that as you move from a higher number below 7, as you go down, go lower, the substance becomes more acidic. Then from the after 7, we have alkaline. So 14 is more alkaline in nature than 8. So it means that from 7, as you increase and go, the substance becomes more alkaline. Okay, this is the pH scale. Okay, so pH scale is basically a way of measuring the acidity and alkalinity of a substance. Then we have pOH. pOH, because we have pH scale and we have pOH. pOH is basically concerned with the non-acidity nature. Okay, the non-acidity what? Nature. Alright. So, with this, we'll come to the end of this class. In our next class, we'll be looking at bases and alkalis. Do well to subscribe to our YouTube channel so that you can get more updates on latest videos. Thank you very much.